All right, our next theorem here is called the side angle side similarity theorem, SAS. So again, it sounds very close to the SAS congruence theorem, but it's a little different. So the two sides are going to be proportional. The one angle has to be congruent because that's the definition of similarity. And because the A is in between the two S's, on your diagram, the A in question has to be in between the two sides. Okay, so we have that language in the theorem that we had last semester. It says if one angle of one triangle is congruent to an angle of a second, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Okay, so what we're talking about here is we've got X and M, the angle. So that means the proportional sides, XZ is in a ratio with MP, and then the other side over here is XY and MN. So see how it creates the angle. So if you were to draw over the two sides, you have created angle X and angle M. So it has to be that angle in order to use this SAS similarity theorem. All right, we have a few examples here where we are going to not prove that it's SAS. We're actually going to create an equation, but we're going to solve for a missing side. All right, to find the value of X that makes triangle PQR similar to triangle TUV. So I can tell on my diagram. So here are I've got my 60s right here that are congruent. So I need a proportion to put the corresponding sides in a ratio. So I'm going to start with 3x plus 4 in a ratio with 20. And that corresponds to 30 over 24. So again, you can reduce 30 over 24 down if you want. I usually leave it, and I'll just use my calculator as I work through the problem. So cross multiply. So I'm going to do 24 times 3x plus 4, and then I'm going to do 30 times 20. So 24 times 3 is 72, so 72x. 24 times 4, 96, so plus 96. And then 30 times 20 is 600. I'm going to take out 96, so subtract 96 from both sides. It gives me 504. So 72x equals 504, and then divide by 72, and I get x equals 7. Now, you can check this. So if I go back to my 30 over 24, okay, you can either reduce it or divide it out. I'm going to go ahead and divide it out and get 1.25, because all I'm going to do is check. When I plug 7 in here for x, and I put the sides in a ratio, do I get 1.25? So PR is going to be 21 plus 4, and so PR is 25. That would be in a ratio with 20. So 25 divided by 20 is 1.25. Okay, so that's just an extra layer of checking that you can do to make sure your algebra worked out correctly and you solved for x. Okay, I want you to pause and do number 5. Find the value of x that makes the triangle similar. Okay, I'm going to go ahead and write the answer up here at the top. You should get 9, okay? If you got 9, you can skip on to number 6. If not, let me work through this example. So 14 times 3x plus 5, 28 times 16 is 448. So let's distribute. So 14 times 3 is 42. 14 times 5 is 70. Take away 70 from both sides. So 448 minus 70 is 378. 42x equals 378. And then divide by 42 is, there's my 9. Okay. All right, ratio and corresponding sides. All right, number 6. so number 6 is going to be a similar setup. It's just the algebra behind it is going to be a little complicated. All right, we have ABCD is similar to BCPR. So just get your bearings. ABCD is the large rectangle. BCPR is this one, okay? Now, they're not oriented in the same way, but we'll look at that in just a minute. Find the exact value of x. So what that means is no decimals. So if it doesn't divide out evenly, actually, no, I take that back. Not no decimals. It cannot be repeating. I guess if it's a decimal, it must terminate. 2.5 terminates, but it can't be like 1.473521 on and on and on. If it's a irrational number and it's a square root, it has to stay that way. All right, let's see the value of x. So x goes with DC. Let's add a little bit more to this picture. So, let's see. I am going to label PC as x minus 2, okay, because it's the whole thing is x. This section is 2, so what's left over is x minus 2. So I've got 2 up here and x minus 2. I guess I can bring this 2 over. All right, so let's start with DC. So DC, let's go by the names up here at the top. DC goes with PR or RP. Okay. So what else do we have labels of? We know AD. So let's see if we can set up AD. So AD are the first and last letters. It goes with BR. Okay, so let's write that out. Let's plug in. So DC is X, RP, RP. Okay, so RP in the middle here is also going to be 2. So X over 2. AD is 2. And then BR at the top there is x minus 2. Okay, let's cross multiply. So I have x times x minus 2, and then 2 times 2 is 4. Distribute in, so that gives me x squared minus 2x equals 4. So it looks like I'm gonna probably factor here. So let's move the 4 over to the left. So x squared minus 2x, so take away 4 from both sides, so that would be minus 4. So let's go ahead. So I'm looking for two numbers that multiply up to -4, add up to -2. So 2 times 2 is 4. So to make that say -4, one of them has to be negative, but that's going to add up to 0. And I can't use 4 and 1 because that won't add up to 2 or -2. So what that means is this does not factor. So my only other alternative here is we're going to have to use quadratic formula, okay? So we haven't done that for a while. So quadratic formula, all right? We have the quadratic formula, first of all, you need to know it. -b plus or minus the square root of b squared minus 4ac over 2a. Okay, and my, I'm going to come up here to the top. So a in the quadrat, or in this trinomial is 1. B is -2, and C is -4. Okay, so let's plug in. So I've got, so x equals -2 plus or minus the square root of b squared, -2 squared minus 4 times a, which is 1, times c, which is -4, over 2 times a, 2 times 1. Okay, so I would recommend just plug in. Don't do any calculations when you plug in. All right. -2, I can simplify to just a 2, plus or minus. So negative 2 squared is positive 4. This is where a lot of people go wrong because you just blindly type it in your calculator. So it's a negative 2 times a second negative 2, which makes a positive number. Minus 4 times 1 times negative 4. So that's going to end up being a positive 16 over 2. Okay, so 4 plus 16 is 20. So I've got 2 plus or minus the square root of 20 over 2. Okay, so I can simplify the square root of 20 because it is not going to be a whole number. It's going to be it's an irrational number. So the square root of 20, I'm going to kind of simplify over to the side here. I'm going to go like this. So square root of 20 breaks down into square root of 4, square root of 5. And the square root of 4 is 2. So I'm going to simplify the square root of 20 into 2 square root of 5. So I now have 2 plus or minus 2 square root of 5 over 2. Now, I can do one more thing of simplifying. Okay, because I want to remind you what we have here. We could separate this out. We really have 2 over 2 plus or minus 2 square root of 5 over 2. Okay, because it's a common denominator. 2's are common denominator. So we could put them together on one fraction. But if you separate them out, what I want you to be able to see here is 2 divided by 2 is 1. And then I have the other set. So sometimes you'll see this. We can reduce down both of those 2's, okay? So when I am done here, I end up with, if I kind of continue with what I separated out, I have 1 plus 2 divided by 2 is 1 square root of 5, which is what I'll get up here if I were to notice 2 divided by 2 on both of them. So in exact form, here is where we are at, 1 plus or minus the square root of 5. Okay, so I wanted to run through that because that is definitely an advanced part of solving. We won't do much with quadratic formula, but I just want you to see it every so often. All right, well that wraps up SSS and SAS.